Okay, so back to, we are going to not only use the skills that we already learned in lesson 5 and 6, how to solve these systems of linear inequalities, but we're going to be able now to also set up our own. We already know how to set up systems of linear equations. So the only difference is they're going to be inequalities now instead of equations. So what did you decide in our problem about Alice having this party? What did you decide we should let X represent? Okay, how much cheddar cheese? And what do you mean? Is it like packages or what is it?
The amount of cheddar cheese per pound.
Yeah, how many pounds? But you know what? Look at here. Look what your teacher already did. Yeah, I already chose that it's going to be pepper jack. So, you know, I love that you guys don't look down there though, and you know, you try and decide on your own. Good job. Okay, so let X represent number of pounds of pepper jack. And we know that pepper jack is cheese, so we'll say for cheese. All right, you got that? If you want to put the cheese, you can. And what would Y represent then?
Cheddar.
Okay, number of pounds of cheddar. Okay. Which is your favorite? Mine is pepper jack. No? All in favor of pepper jack? Oh darn you! I'll have to take the rest of the notes now. Oh, except Mrs. Allen. She's not bored with me. Oh no, too late, too late. Okay, so what other information should we write down here? She wants what?
Yeah, at least 2 pounds of each.
At least 2 pounds. So in other words, this is not an equation. It doesn't say she wants exactly 2 pounds of each. It says she wants at least 2 pounds of each. Which inequality symbol do you think represents at least?
Greater than or equal to?
Greater than or
Equal to.
equal to. So it can be that, and it has to be more than that. So greater than or equal to. So that right there tells us, you know what? We better be working with that inequality symbol. At least. Okay, so now using the information that we were given, that she is serving both of these types of cheese, and she wants at least 2 pounds of each, wants to spend at most $20. What does that mean?
She wants less than or equal to.
That's her limit, yeah. So at most, so that would be is less than or equal to, wouldn't it? At most. So this at most tells us that we're going to have is less than or equal to for that part. Pepper jack sells for $4 per pound, and cheddar sells for $2 per pound. Oh, I have better taste than you do. My cheese costs more. You guys like the cheap stuff? I'm just kidding. Okay. I am going to tell you right now that we need to set up 3 linear inequalities for our system. Anybody think they know one of them? Go ahead and try and write one down on your paper. Try it. Or, Cody, don't speak up. Ever go ahead and write one down on your paper that you think. Let's, you know, see if we can come up with at least one on our own.
Should we write the second one?
If you got one and you're feeling pretty confident, move on to the second one. Sure, we'll wait for everybody to get at least one. I thought you said you wanted to write another linear inequality. I didn't say about solving. You said, can we write another one if we want?
Just trying to get it done instead of.
Well, go ahead and just work away and then let's see if you have to erase it all. Okay, anybody want to share their linear inequality that they came up with? Well, let's put it like this. You are going to, somebody's going to. Noah, thank you.
2y is more than. I have trouble saying the symbols.
More than
Greater than or
Cody.
equal,
Is greater than or equal to, is that what you want?
yes.
Okay.
Then 12 plus 4x. Oh wait, no, 20 plus 4x.
So this to be a 20 here. Here's what this tells me. That the cheddar cheese sells for $2, since it sells for $2 a pound, this tells me how much money is gonna be spent buying cheddar. Are you staying with me here? This is how much money is gonna be spent buying cheddar cheese. And then this 20 tells me that, you know, this is money, so this is money, a one-time thing, so add that to the money spent on pepper jack because it's $4 per pound. So the pepper jack cost plus the $20 will be, if I read this backwards, less than or equal to the amount of money that you're going to spend on cheddar cheese. Think that'll work?
Should it be?
Or maybe we could just read it from the front, maybe make it, so all the amount of money spent on cheddar cheese is going to be more than or the same as $20 plus the money spent on pepper jack cheese.
Should it be minus 4? 20 minus 4?
Okay, so now we're going to take the amount of money we spend on pepper jack cheese, take it away from the 20, and our cheddar should either be equal to that amount of money we spend should be either equal to that or more than. It's very possible it could be like that, but I think we could make it start better to make better sense. Cody?
Should we start it at like 2y plus 4x is less than or equal to 20?
Okay, so then we would, so if we change it to that, if we have it as 2y plus 4x, oh, you can tell you guys really do like cheddar cheese, it gets to be first. So 2y plus 4x, the amount of money spent on cheddar cheese plus the amount of money spent on pepper jack cheese is less than or equal to $20. How do you feel about that one? Okay, and so notice, if we rearrange this one, we would be subtracting 4x from that side, wouldn't we?
Yeah.
And we could get away with that, couldn't we?
Mhm.
Yeah. But does it make more sense this way, that we're adding the amount we're going to spend on each type of cheese, and at most, we're going to spend $20? Okay. Okay, another one. Okay, Cody, what do you think you got?
Y is greater than or equal to x plus 2.
Y is greater than or equal to x plus 2. Okay, so this tells me that the amount, the number of pounds of cheddar has to be more than or the same as pepper jack cheese plus 2 more pounds.
That's basically my first one, except for it's been divided by 2.
Can I change my mistake?
You want to revise it already? Okay, go ahead and revise it.
Oh, I think I should have put it x plus y is greater than or equal to 2.
Okay, so now
Because pounds of cheese plus pounds of cheese equals pounds.
so pounds of
Cheddar
plus pounds, or pounds of pepper jack plus pounds of cheddar is what?
equals pounds.
Equals?
Or is greater than or equal to pound of cheese pounds of cheese. 2 pounds of cheese.
Okay. Seriously, all this cheese is starting to, make us talk funny. So pounds of cheese, one type of cheese plus pounds of the other type of cheese is supposed to be at least 2 pounds. Oh, but I thought you wanted 2 pounds of each.
And then you have more than, hence the greater than.
How can we be guaranteed? Because, I'm thinking of some numbers for, like X and Y that maybe would be, if I just buy any pepper jack and I bought 1 pound of cheddar, now that wouldn't satisfy it. Well, what if I buy 3 pounds of pepper jack then and I buy 0 pounds of cheddar because I really want pepper jack? 3 plus 0, that's 3, that's greater than 2. Well, then I didn't buy 2 pounds of the other one like I'm supposed to. Yes.
It doesn't say
Would it be
so.
like, is it possible to be like 2x plus 2y is less than or equal to 20?
Okay, so now 2x, did you say? Plus 2y. So when we take 2 times x, That's pounds times pounds, that becomes square pounds. I don't think that would work. Or,
So, if you want 3 pepper jacks, and no cheddar, do you want us to put an equation like 3x is greater than or equal to 2?
well, we're getting really close, but if we do it like 3x, then we're saying that the pounds of cheddar, or the pounds of pepper jack are $3 a pound. Let's take that 3 out there. What if we had, Cody?
Okay, so I think what you're trying to say is in the paragraph or so, whatever it is, it says she wants 2 pounds of each. So if we went 2x plus 2y is greater than or equal to 2.
So
We're gonna see what Aurora's thought over here, so put right of your out from it, huh?
So we're just saying that 3
Yeah, and then what would that say?
x is greater than or equal to 2.
So x, the number of pounds of pepper jack cheese, has to be greater than or equal to 2. Wouldn't that be buying at least 2 pounds of pepper jack? I like that. So x, I'm gonna move my is greater than or equal to over, just x is greater than or equal to 2. The number of pounds of pepper jack I wanna buy has to be at least 2 pounds.
So then wouldn't it be the
What
same
would the
for
third one be?
Y?
And then would be the same thing for y, because that
You'd
one we
2
want.
pounds of each.
Yeah, there you go, that's what we do. We gotta have pounds on both sides. You guys were trying to take pounds times pounds and say they were still pounds, you can't do that. You can add pounds and they stay pounds, but you can't multiply. And so, there's our system of linear inequalities ready to graph. Okay, so now, let's get them ready, those 3 ready to graph. So we'll take our first one, which is in what form? What's that form in that first one? Standard form. So we need to get it into slope-intercept form, so we'll do that first. 2y plus 4x is less than or equal to 20. So go ahead and get that one rearranged for y. After you have that one ready, go ahead and get it graphed, shaded, the whole works, do it all. Before we even move on to the others. We gotta do these one at a time so we don't get too confused. Oh, we gotta label your graph, don't you? Hey, what's the x-axis going by? 0.5 by a half. And what's the y-axis going by? 1. Oh, that's going to create an issue here. So we gotta stop and reflect after we get it labeled. Okay, let's get it labeled. Okay, do we all agree that the y-intercept of this one is 10? Yes? Did you all get that? Okay. And do we all agree that the slope is -2? Okay, -2 means do what on the graph? Stop it, Cody. -2 means what on the graph?
We're going down.
1, 2,
We're going down 2 and right 1. Oh, but remember that means we're going down
So we're going
2
down.
pounds and over 1 pound. So can we go by grid lines on this one?
No.
No. So we have to say, I gotta go down 2 pounds and over 2 for 1 pound of the pepper jack. Down 2 pounds and over 2 grid lines so that I go 1 pound of pepper jack, because it's 2 over 1, -2 over 1. So we have to be careful. Remember, sometimes our slope, we have to process it through what we're actually doing because the scale isn't 1 by 1. Okay, so you should end up at 5 on the x-axis, it looks like, right? Okay, solid or dash boundary line for this one? Solid, okay, and let's do a mental math one because we could do the origin. I'm gonna let you do a mental math test point here, okay? So, what are we gonna end up with? We're gonna end up with 0. Oh, like we can't really, we gotta do it in the standard form. What am I doing? If we put 0 in both of these, we get
0.
0. So is 0 less than or equal to 20?
Yes.
True, right? So where should we shade?
Below.
Below. And should we go outside of quadrant 1?
Yeah.
If we go outside of quadrant 1, then we're saying we got some negative pepper jack cheese and we got some negative cheddar cheese.
No, don't go out
Okay.
there.
So we just got this nice triangular region. Oh, I'm trying to do it with a line. Okay, you shade with whatever you're going to shade with. I gotta grab myself a pen instead. So this is one that we just have that nice little triangle there that's going to be shaded. Okay, now let's take our other two and let's put them here. X is greater than 2, and then we have Y is greater than or equal to 2. X is greater than or equal to 2, Y is greater than or equal to 2. What's true about that X? Yes, Julia? Okay, what is that X one? What kind of a boundary line would that be?
Horizontal.
Yeah. Oh. So, I'm sorry, what?
A horizontal line?
I said this is a horizontal line? This one right here?
Yes.
It's a
Vertical.
vertical. This is vertical. Where is it going to cross? If it's vertical, it's got to cross the x-axis. Where is it going to cross at?
2.
2. So we're going to go put a point at 2 on our x-axis. Should we put a solid or a dash line?
Solid.
Solid. Should it go below the x-axis? No, it should extend up. And it's a ray this time. It can keep going that direction, but it can't go below the x-axis into negative territory. So we're first going to draw our solid vertical line. And then we're going to say, well, if we can we test 0, 0?
No.
It's right here.
Well, yeah, we can.
Okay, so we put 0 in for x, right? 0 is 0 greater than or equal to 2.
No.
That's false. So should we shade this side then?
No.
We should shade that side, right? Okay, so now we're going to shade this side of that vertical line lightly, because we got to have 3 shadings after this time. We're going to quadruple shade this one when we do our overlap region. And you need to extend and put an arrow so that you can tell that, because you're on a grid line on there, right, with this vertical line. So get a nice solid boundary line with an arrow at the top, extend it beyond so you can tell there's a boundary line there. Okay, and then our last one here, what kind of a line do we have for that one? This one's horizontal. Where is it going? Where are we going to put a point for
2.
that one? At 2 on the
Y-axis.
y-axis, and we're going to draw ourselves a solid or a dashed boundary
Solid.
line. A solid one. Extend it beyond so that you can see you have one there with an arrow at the end. Okay. Is the origin testable?
Yes.
Okay. So we put 0 in for y. 0 is greater than or equal to 2.
False.
False. So that means we would shade below this or above it?
Above it.
Above it. Okay, so now we're going to shade above our horizontal line. And by the time we're done, just this whole graph's got shading somewhere, right? Crazy thing. So we're shading above our horizontal line, so everything above is shaded in quadrant 1. There is not a place on the graph where it has not been at least single shaded, double shaded, or triple shaded. What is our solution region? Which of those?
The small triangle in the center.
Yeah, the triple shaded region is where we are going to now clearly show that this is, oh, I got a little bit below. What is going on out there? Here's our, making mine a peaky purple so that you can see where your triple shaded region should have turned out. So any point within that triangle is a solution, is a combination of cheese you can buy. How about the sides that make up the triangle?
Yes.
The points on those sides count?
Yes.
All three sides?
Yes.
Why?
Because they're all solid.
Because they're all solid. Okay, now it says give 6 possible combinations. Hey folks, we don't give them as ordered pairs. That's useless information in this situation. We give them as what can she go to the store and buy and satisfy not spending more than $20. We give you 2 pounds of each type of cheese at least. So give us one combination.
Alice can buy.
No, we didn't even have to write a sentence. Just tell me, give me how many pounds of pepper jack, how many pounds of cheddar?
3 pounds of pepper jack, 4 pounds of cheddar.
Okay, so right
Yeah.
here.
Yep.
Are you convinced that the boundary line is going through there? Was it one of our points?
Yep.
Okay, so we can say 3 pounds, and we'll call it PJ for pepper jack, and 4 pounds of CH for cheddar. Okay. No code, you already gave one. Feel free to throw one out, Calvin. Feel free to throw one out, Noah. Okay, you ready? Okay.
3 pepper jack and 3 cheddar.
Oh, that'd be right smack dab right there. I think that would count, wouldn't it? Okay, 3 pepper jack, 3. Oh, what did I just do? Oh my goodness. Okay.
Whoa.
Yeah, really. Okay, you guys just keep writing. Just ignore me. Okay. 3 pounds of pepper jack, 3 pounds of cheddar. And don't look at mine. It's whacked out right now. I moved it somehow. I don't know what to do. Well, let me see. Maybe I can undo a move. Yeah, I did. Okay. Just gotta know what you're doing. 3 pounds of pepper jack, and I didn't change colors. And 3 pounds of cheddar. Okay, let's be creative. Does she have to buy them in exact pounds?
No.
She's going to the deli case where they'll cut out whatever you want. Okay, what's another choice then? Michaela.
2 pounds of pepper jack and 4 pounds of cheddar.
Okay, 2 pounds of pepper jack and 4 pounds of cheddar. I wrote it before I checked you out here. Yeah, it's right there on that boundary line, isn't it? Okay, I want a partial pound. Abby?
2.5 pepper jack and 3 cheddar.
And 3 cheddar right there. 2.5. So 2.5 pounds of pepper jack and 3 pounds of cheddar. We got 4 of them. We got 2 to go. She has lots of combinations of what she can do. Aurora?
3.5 pepper jack and 3 cheddar.
And 3 cheddar. So 3.5 so right here. Okay? So we're pretty convinced she can do that? Okay, how can we make sure what if you can't tell that that's a point in the graph? How can we, let's write it down first of all. 3.5 pounds of pepper jack and what did you say? 3 pounds of cheddar? Okay, well, we'd multiply how much they cost, right? Pepper jack cheese is $4 a pound. What's 4 times 3? 12. What's 4 times a half? 2. So she's going to spend how much money on pepper jack?
$14.
$14. Cheddar is $2 a pound. 3 times 2? 6. 6 plus 14.
20.
She wants to spend no more than $20. Are we safe?
Yeah.
Good job. Okay, you guys get your 5th one on your own. You can do it. come up with one that's gonna work. And if on the quiz, when you take
We
the
already
quiz,
have our quiz.
Which means.
you gotta have 6. I'm sorry, you gotta come up with your own 6. So when you are doing these, it's always when you're like, oh, I'm not really sure, do like we just did. Plug in the numbers and make sure that when you multiply it out, you're not spending what you're supposed to, or whatever the case is. Anybody have any questions before I close out here? Cody?
Would 4.1 pepper jack and 2 pounds cheddar work?
I'm gonna say it's possible, but I don't know. So
Can we check?
4.1 and 2, is that what you said? Okay, so 4.1, so remember pepper jack cheese is $4 a pound, so $4 times 4 is,
16.
okay, and then another 1/10 of a pound. How much would that cost if it's $4 a pound?
A cent?
40 cents.
40 cents.
So now they've spent $16.40 on pepper jack cheese.
Yep.
Okay, how much is cheddar cheese again? $2.
$2.
You want 2 pounds of it, because we gotta have at least 2, right? It was 2. What's 4? 2 times 2 is?
4.
Oh, what's 4 plus $16.40?
$20.40.
40 cents too much. Does that one work, Cody?
Yes. Good change in your pocket.
No.
Okay.
All she has is a $20 bill.
All she has is a $20 bill. She's not gonna, she's not gonna beg, borrow, or steal. Okay.
Unless Marty gives her money.
Yes.